Hello, welcome back. Today we're going to be continuing our series on graphing rational equations. If you haven't taken a look at the first video in the series, how to fully factor your rational equation, take a look in the comments, go look at that, come on back. But here we are at step number 2, which is how to find the x and y intercepts, any holes, and to plot them. Okay, so first, let's just take a quick look back at the whole scope of where we're headed, and then we'll go ahead and get to work on today's task. Okay, so just to remind everybody, we're graphing rational functions. In the first video, we fully factored the numerator and the denominator, and so here we are today at step 2. Find the x-intercepts from the zeros of the numerator, the y-intercepts from plugging 0 in for x, identify any holes, factors common to the numerator and the denominator are holes, and then plot all intercepts and holes. All right, and then you can see all of this is where we're headed next, but today we're here at step 2. So the first rational equation we'd been working on was this, and last time we completed step 1 and we factored fully numerator and denominator. So today we're finding our x-intercepts, our y-intercepts, and our holes. Okay, so to find our x-intercepts, we find the zeros of our numerator. So what does that mean? Well, we take a look in our numerator here. We have only one factor. We take that factor and we set it equal to 0 and we solve it. And if we had multiple factors, we'd do the same for each of them. So x minus 3 equals 0. Opposite operations tells us we're going to add 3 to both sides. X equals positive 3. And so that is the x-intercept, where it intersects the x-axis, which means our x is a value of 3 and our y is a value of 0. To find the y-intercept, we plug in 0 for x. Okay, so as we take a look here in our equation, when we plug in 0 for x on the top, we get negative 3. When we plug in 0 to this factor, we get negative 4. And when we plug in 0 to this factor, we get 4. When we put that all together, we get negative 3 over negative 16, which simplifies to just 3 over 16, which is approximately 0.19 as found on my calculator. Okay, so again, our y-intercept, that means it's where it's hitting the y-axis. So our x is 0, which is why we plugged in 0 for x. And we found out that that was approximately 0.19. Now, are there any holes? Well, we look in our numerator and we look in our denominator, and we do not have any factors that are common, that are exactly the same. So that means we do not have any holes. So now if we go ahead and head over to graph paper, I'll sort of put that up there. We're going to plot our zeros and our intercepts. So the x-intercept, we are over 1, 2, 3 and up 0. And our y-intercept, we are up 0 and we are over 0 and we are up 0.19, which is approximately 1/5. So there we are. So those are the 2 points that we gleaned from this step. Okay, let's do it again. So here's the next equation that we had been working with. And you can see again, we used our x method to fully factor top and bottom. Okay, so for our x-intercept, we know that that's the zeros of the top. So we're going to take each of those. X minus 2 equals 0. X plus 3 equals 0. Using opposite operations, I get that x equals 2 and x equals negative 3. And that gives me the points 2, 0 and negative 3, 0 as my x-intercepts. My y-intercept I know I'm going to plug 0 in for x, and hey, take a look. I have just plain x on the bottom of this fraction. So that means I'm going to end up with -2 times +3 over 0, which does not exist. I do not have a y-intercept. It doesn't cross the y-axis. Okay? And so then if I go ahead and I bring some graph paper over, so I've got my two x-intercepts. I've got over 2 up 0, and I've got over -3 up 0. And I do not cross this y-axis. That means the y-axis is an asymptote, and we'll get to that in the next video. And then finally, if I take a look at this equation we were working on. So again, here's our rational function. Here's our factored form to find my x-intercept. Those are the zeros of my numerator. 4x equals 0. X minus 1 equals 0, x equals 0, x equals 1, right? By doing opposite operations, dividing by 4, adding 1. So that means I have the points 0, 0, and I have the points 1, 0 for my x-intercepts. For my y-intercept, I'm going to throw 0 in for x. And hey, look, I have the factor 4x. When I put 0 in there, this is going to be a 0. 0 times anything is still 0. And then that big 0 divided by anything is still 0. And just to show you what that looks like, 4 times 0 times -1. Divided by -1, divided by 2. And again, because of this 0 up here, this whole thing just resolves into 0. So my y-intercept is that same 0, 0 point. So I am going to grab a final piece of graphing paper. I am going to do my x-intercepts at 0, 0 and at 1, 0. And my y-intercept is that same 0, 0. Now, the one thing I forgot to do here is check for holes. So let's go back to this one. And lo and behold, hold on. X minus 1 is on the top and the bottom of the fraction. That means that when I put 1 into this equation, I'm going to end up with a 0 on the bottom of my fraction, and that can't be. And that's what makes this a whole, because I also have it on the top. So instead of this being an asymptote, this actually looks like a hole right here. So instead of having a filled in dot, I actually would have an empty space, and whatever my function is doing at that point, it gets infinitely close to this and continues infinitely close on the other side, but does not actually hit it. And so that's what a hole is. And so just to review one more time, that was step 2. We found the x-intercepts from the zeros of our numerator. We found the y-intercept by plugging 0 in for x, and then we remembered to check for holes, factors that are common to top and bottom, and then we plotted everything. Okay, so that is completing step 2 on all 3 of these functions. Practice that, go back and check out the factoring if you need to, and then tune in for part 3, where we're going to figure out how to find our vertical asymptotes. Okay, keep working, and as always, keep mathing.